Hey Julian, welcome to another video lesson. Week number 22, days 1 through 5 is what we plan to do tonight. And let's start with day 1. Which conclusion can you draw about worker productivity based on the scatter plot? And here's the scatter plot. We have hours worked on the x-axis and units produced on the y-axis, as you can see. And the general trend, as we can see, these dots that you see, they're actual numbers. So kind of like if you look at this dot, it tells us that somebody who has worked for somewhere between 8 and 9 hours in a day has produced a little less than 2 units. On the other hand, somebody who has worked for, let's say, only 2 hours has managed to produce as many as more than 9 units, right? So what does it tell us? The less you work, the more you produce. So it's kind of saying that if you increase the number of work hours, your productivity decreases as per this scatter plot. The reason could be like you get fatigued, you get tired, you get bored, and therefore the productivity decreases. So here are the options. Productivity increases during the work day. That's wrong, because during the work day, as the number of hours worked increases, we see that the units produced keep coming down. So it doesn't increase, the productivity doesn't increase. There is no trend for productivity in the scatter plot. Even that's wrong. There's a clear trend that shows us that the productivity decreases with time, with the number of hours worked. See, as the workday progresses, productivity declines. Yes, this is the one. As we can clearly see, the productivity declines as we produce, or as these workers work for more and more number of hours in a day. And finally, D, productivity remains constant during the workday. If that were to be the case, then this would be pretty much like a straight line. So all the dots would be around the same value on the y-axis if it were to be constant throughout the day. So the obvious choice is C. Done. Let's move over to day 2. Why is this bar graph misleading? Now here's a bar graph. I hope you understand what a bar graph means. You have bars of different length. So this is for A. Now A could be anything. It could be representing a person, a place, or anything. You know, you have A, B, C to compare, and you have the bars of different sizes, different heights. Now there's something to notice over here. Now on the y-axis that has got the numbers, you start at 0, then it's a 10, then it's a 20. That's fine. So equal increase, and after that I see a 20 to 40. So this jump, even though this interval out here, this one, looks to be the same length as this one and this one, but they're actually unequal, because this one is 10, this one is another 10, but this one is 20 to 40. That's a 20, a jump of 20. And similarly, we have a 40 and an 80. So from here to here, it's actually a jump of 40. So this is clearly misleading, right? And over here, from 80 to 160, so the jump is 80. It seems like it keeps doubling. Now as you look at the bars, for example, if you look at B and if you look at C, it might seem that the difference between B and C is as much as the height of A, that is 10, but it's not really so, because the value that corresponds to B is only 40 and the value that corresponds to C is 80. So it's a jump of 40 over here. Even though it looks like a jump of 10, it isn't. It's misleading. So now let's look at the options. F says the scale is not divided into equal intervals. Yes, that's right. So the differences among the data seems less than they really are. And that's absolutely right. You look at B and you look at C, the difference between B and C looks to be 10, like I said, but it in reality is equal to 40, the difference in the data. Similarly, if you look at A and you look at B, it seems like B is 20 more than A, right? Because each of these lines, the difference between them seem to be 10, but it's not so. A to B, B is 40 and A is 10, so the jump is actually 30. So clearly it's not linear. So F looks like the right option. Let's look at G. The horizontal scale does not start at 0, which skews the data. Horizontal scale? What are you talking about? We have A, B and C, the three bars along the horizontal direction. We don't have a scale. We don't see numbers here, right? So this cannot be right. There's no scale in the horizontal direction. Option H, the scale is not divided into equal intervals. Yes, I agree, the scale indeed is not divided into equal intervals, but that's what the first option says as well. So the differences among the data seems greater than they really are. Now see the difference between this one and this one. The first option, F, says that the difference among the data seems less than they really are. This one says the data seems greater than they really are. Now if you look at this and this, the difference seems to be 10, whereas really the difference is 40. A jump from 40 to 80 is 40. So the data clearly seems less than it really is, right? So F looks more correct. The data doesn't seem greater than it really is, or they really are. So this is gone. And finally J, the bar graph is not misleading. No, that is misleading due to this fact. The scale is not linear. So F is the right answer. Right, let's move on to day 3. An aquarium in the shape of a rectangular prism has a volume of 2160 cubic inches. It has a length of 15 inches and a width of 12 inches. What is the height of the aquarium? Okay, so this is a rectangular prism we have. Pretend that this is the aquarium in question on day 3. So it's given that the volume of this aquarium V is equal to 2160 cubic inches. And it's also given that the length is 15 inches, and the width is 12 inches. I think I could have dropped the inches. 15 and 12. We need to find the height. We need to find how much is this, right? So just as you know, the volume of a rectangular prism is length times width times height. So that means if we name this as X or a H maybe for the height, I'm using X. So it's going to be 15 multiplied with 12 multiplied with X. That gives the volume, which is 2160. Therefore X is going to be equal to, you know what to do, divide both sides with 15 and 12. Do not multiply 15 with 12. You don't need that. So this is 2160 over 15 times 12. And we could actually simplify this, you know. So as I see a common factor between, you could have started simplifying with 2, but that would take more steps. So I'm thinking 5, because 5 goes into 15 and 5 goes into this number as well, because in the end we have a 0. So cross it off. 5 times 3 is 15, and then 2160, I think that's going to be 432. There you go. 432 over 3 over 12. Now a quick check, if 3 can go to 432, you know how to do that. 4 plus 3 is 7, plus 2 is 9. So 3 can go to 9, therefore 3 can go into 432. And 3 can go to 420 140 times. So this is going to be 144. And the 3 is gone. And finally 144 over 12 is 12, because 12 times 12 or 12 square is 144. So we have X is equal to 12. So the height is 12 inches, which is option B. Day 4 says Ben is building a wall. What length of wood does Ben need to buy to create 2 cross beams for the frame? Round your answer to the nearest tenth. So this is the frame. As you can see, it's in the frame, it's in the shape of a rectangle with 3.7 meters on one side and 2.1 meters on the other side. Now the length of the cross beams is actually this length that you see over here plus this length. Now the two lengths obviously are equal, so you can find either one of them and multiply that with 2. That should give you the total length of the cross beams, and that of course would be the length of wood that he needs to buy to create those cross beams. So let's get started. Let's start by drawing the rectangle. So we have our rectangle. This is 3.7 meters, this is 2.1 meters, and then, although not explicitly mentioned in the problem, we need to make an assumption this is a 90 degrees, and I believe that's a fair assumption. So in a room you have the walls that are at right angles to each other, and this does look like a rectangle, and most importantly, if this is not a rectangle, you will not be able to solve the problem. So you have to assume that this is a rectangle. Okay, now how would you solve the problem if this is a 90 degrees? Simple. You need this length, right? We need this length. Now if you look at this triangle, this is a right triangle, so you could apply the Pythagorean theorem on this triangle. So let's say this length out here is a C. Why C? Because the Pythagorean theorem tells us a square plus b square is equal to c square. I mean, that's the way most students would like to remember it. So we have, as per the Pythagorean theorem, a square, that is the square of the length of any of these two sides, plus b square, that is the square of the length of the other side, the one that you didn't take in A, is equal to c square. So c square, this length square, c square is equal to a square. Let's say this is a 3.7, so we have 3.7 square plus b is this 2.1 square. Okay, so this is going to be equal to c square is equal to 3.7 square is 13.69. Now I just dropped the units, meters. Let's work with the numbers. We can put back the unit in the end. Plus 2.1 square is 4.41. So if you add these two up, you get c square is equal to 13 plus 4 is 17, and this is going to be 1.1, so this is 18.1, and therefore c is the square root of 18.1, which is equal to 4.25. that's in meters, this length, right? Now we need to find out the wood that Ben needs to buy to create both these beams. Therefore it's going to be 4.25 times 2 beams, so that is 8.5 meters. That's clearly option H. Done. And finally we come to day 5. If this pattern continues, how many circles will be in the 8th group in the sequence? So here's the first group, here's the second group, here's the third, the fourth, the fifth, and so on, right? Okay, so in the first group we see there's only one circle. Let's write C for a circle because there are other shapes as well. In the first group there's only one C. Now in the second group there's a circle and a triangle. In the third group there's a circle, a triangle, and a rectangle. R for rectangle. Yeah. In the fourth group, another circle adds to this sequence actually. So you have a group of 3 and then you repeat. So you have a circle, a triangle, a rectangle, and another circle. So this is going to repeat for 4, 5, and 6. They will all have 2 circles, just like 1, 2, and 3. They have got 1 circle each. 4, 5, and 6 will have 2 circles each, and after the 6th pattern, that will be 2 bunches. That will be the 6th one will be 2 groups of a circle, a triangle, and a rectangle. So the 6th group will look like this: a circle, a triangle, a rectangle, and a circle, a triangle, and a rectangle. Now this is the 6th group. Now the 7th one, once this pattern is completed, every group of 3 keeps adding. The 7th one will add another circle to this, so it will be this one and another circle, correct? So that will be 3 circles, 1 circle over here, 1 circle over here, this one, and another one in the end. And therefore the 8th group which doesn't add another circle, what does it add? The 8th group will add a triangle. So the number of circles is still the same. It's 3. Option B is correct. Right, so that's it. That's day 1 through 5 for you. I hope you go over the solutions and make sure you understand them. Any questions, just let me know. I'll see you next week.